Hello, everyone. Welcome to today's webcast about using SOLIDWORKS CAM and CAMWorks in your shop. I'm the moderator, Krista Prokos. Before we get started, I want to let you know that you can submit questions for today's presenter by typing them into the Q&A panel at any time. We'll collect them and address them at the end of the presentation. Now, I'd like to introduce our presenter. We're happy to have with us today Fisher Unitech's CAM specialist, Daniel Sock. Daniel, take it away.
Thank you, Krista. All right, let's get started here. So a little bit about myself. I've got over 15 years of experience in the CNC manufacturing world, and a lot of that experience has been within the OEM machine tool industry. I've worked for companies like Mazak and Makino, and I've done everything from helping your small job shops implement their new tools all the way up to executing full CPK runoffs for some of your better-known Fortune 500 companies. My experience is within turning, mill turns, horizontals, vertical mills, and EDM, both wire and sinker. But as a specialist, I was a 5-axis mill turn specialist, especially on the Intergreg systems. And on the EDM side, I worked within the die mold industry of Makino as a wire and sinker specialist. But last but not least, I am also a certified SOLIDWORKS CAM professional. So on today's agenda, we'll be talking about SOLIDWORKS CAM powered by CAMWorks. And we're going to ask the questions, or answer the questions, what is SOLIDWORKS CAM? What are the key features within it? And we're also going to delineate the differences between the standard product and the professional. And then at the end of our web series or webcast, we're going to go into a Q&A session. All right. We're going to first start with just a brief overview of SOLIDWORKS CAM. It is CNC programming inside SOLIDWORKS, so you're not opening up a separate software altogether to do programming. If you've already started up SOLIDWORKS, you have access to the CAM. And it's powered by CAMWorks. And CAMWorks is a pretty well-known CAM out there. It has been around for a while, and it's designed to work natively within SOLIDWORKS. Because it's got a pretty innovative approach and it's easy to use, these are some of the reasons why SOLIDWORKS decided to align themselves with CAMWorks. They found value in it, and they chose to adopt the CAMWorks engine to power SOLIDWORKS CAM. So when you get into the higher levels of capability, something that's beyond SOLIDWORKS CAM itself, you're probably going to find yourself entering into the CAMWorks product. But for today, much of the focus is going to be on SOLIDWORKS CAM and what it has to offer. Things like part and assembly machining. We're going to cover some 2.5-axis milling. That does allow for 3+2 positioning, and 2-axis turning, which is essentially lathe work. There's toolpath simulation included with it, and it comes with a comprehensive library of post-processors, a free set of post-processors. If you've got yourself a conventional Haas mill lathe, a Mazak, or even something that's Heidenhain controlled, you could possibly find a good post within it. And with that, we're just going to go ahead and jump right into a demo. Okay, so I'm going to go ahead and pull up my part here. And it's going to be a turned part. So you can kind of see that this has got plenty of features on the OD. You got some grooving, tapers. This is a taper that is more than your 5-degree typical clearance of the CNMG. So I do want to show that this will machine with the correct kind of tool pathing for it. You'll be aware of that when we see the simulation. Got an OD and an ID. So if you turn stuff like this in your shop, this is going to be something you'll probably appreciate this demo here. So I'm going to define the machine. Oh, before I do that, and I want to show you how quickly this can be done, I'm just going to go ahead and set a stopwatch. Okay, so I'm going to define the machine. I'm going to go to this and turn it into a turned part and use a turning post-processor. I'll say OK. In my stock manager, I'm going to add some bar stock in the back for chuck on and maybe a little bit for the face here. Okay. I can extract my machinable features. I've got all my features here lined up. Generate the operation plan. Okay. This is all the necessary operations I'm going to do. Generate the tool path and then post-process. All right, so let's just stop right there. That is under a minute, and in under a minute, I have code. So this is good code. I know because I've confirmed it before, but to prove it and to show you that this would work, I can go into my simulate, and I can simulate the toolpath itself. And when I was talking about the CNMG and the clearance, this is what I'm talking about here. It's going to leave stock because it's aware of the geometry of the tool. And you saw the DNMG that followed cleaned it up properly. So it does select the right tool pathing or the tool strategies, the right tools to accomplish those strategies, and it will tool path correctly automatically. If I want to check my tool pathing itself to make sure there are no gouges or any kind of missteps with my programming, I can go ahead and hit the Show Difference button right here. And what this does is it shows the difference between the part model and our simulated cut model. And this is our scale right here. The green is actually a nominal, so that's kind of exactly where you want it to be. And this is green all over, which tells me that this is a good part, and it confirms my tool path. So I did all of this with a couple clicks here and there. I didn't really have to navigate too many parameters. If I wanted to, I could just double click on the operations themselves and change the way how the tool path worked out. Maybe I want to change the feed and speed. Maybe I want to change the depths of cuts. And these are things that when you make these changes, you can save them. If this is a tried and true turning process that you do, then you can repeat those processes and have them automatically employed by just generating the toolpath. These major buttons right here can do all your work as you go through the software. And it's not a magic button right away. It's great to start, but when you start editing, when you start changing little things here and there, and you save those changed parameters, the software learns from you, and it becomes just as smart as you are when it comes to machining. So all of this done in less than a minute, and the point is not that this is fast. I don't care how fast it is oftentimes. I just care that it's easy, that it's simple to return to and do over and over again. Less clicks, less mistakes, less scrap. Those are important things for me. So if I have set this up enough where I know that the parameters are tried and true, and I have good results, it will always do that. It will just repeat those results over and over again. Okay? So that is your basic turning. If you've got lathes in your shop, you can do this kind of stuff very quickly and easily. All right, so we're going to talk about what makes great. And I'm going to be honest with you, I was an end user not long ago. And as an AE for other companies, I had a lot of CAM thrown at me. When you represent a tool company, the CAMs want you to use their product because if you're the tool provider and the person buying that machine tool sees that you use that, they're probably going to want to stick with what you do or what you use. So, Master CAM, NX, Esprit, PEPS, all those things, I used them in the past. And I've never programmed faster than I have now. I've never had it so easy. And when we talk about what makes it great, one of the biggest things, and what makes it pretty unique, is a combination of things. But the first part is the automatic feature recognition. If you have a lot of prismatic geometry in your models, these will automatically pick up. And when I go ahead and execute the extract machinable features, it's essentially reading your models and finding these features. So when these features are found, they assign operations and they assign strategies to it. And these are derived from the knowledge-based machining. There's a database that gives you really good strategies, tried and true philosophies of machining, extracts those strategies and applies them to the proper features. So as opposed to before, other CAMs would be operations-based as opposed to feature-based machining. So they would go ahead and have to choose, first of all, I'm going to decide, okay, I'm going to mill, and I'm going to use this tool, and then I'm going to use these parameter sets to go ahead and do that, or I would pick the features, and when I'm picking the features, I got to go ahead and search around in just a really cumbersome modeling environment, not as nice and clean and intuitive as SOLIDWORKS itself. So those are all just like really difficult things to go through, and it's also time consuming. When you work from the feature on down, those principles get applied automatically if they can be. So if you if you don't have lathes in your shop and you want to see an example of milling, we can go right into that. All right, so let's pull up a mill part. Okay, so we don't have just a part here, we have an entire assembly. And what you saw before in the turning demo, that was a single model, a single part file. And this is an assembly model, an assembly file, and it's got various parts all mated in there to create a whole assembly. And in this case, it is a multi-part setup placed on some kind of a tablet fixturing. And you've got about 18 parts here, all identical. And this is, pretty common production setup for a lot of places. And this is one of the nice parts about SOLIDWORKS CAM, is that you can access the assembly files and actually work within that environment. So if you happen to have some complex fixturing or clamping involved, you can set up void zones, you can set up clearances over those particular clamps just to account for any possible interference. And that's something you cannot do on the model side easily. And you would have to, on the part side, the single part side, you'd have to actually draw some of the avoid zones themselves and then set the parameters for it. This one, the models are already setting the parameters for you. So again, this is something where I'm going to go ahead and just simulate a normal workflow. And I'll tell you right now, when I was programming with other CAMs, this would have been not much of a headache, but a slight headache, just because I know that I would have to program just a single part itself. And with that, I would probably do a main to sub programming routine. So M98 to M99 setup, and then assign work positions for all the parts, or all the rows maybe, in this case. So a lot of handwork, a lot of extra stuff that you have to do, things that actually could be handled completely within SOLIDWORKS CAM. So I'm going to go ahead and define the machine. I'm going to say this is a conventional 3-axis mill, and the post processor is fine. And I'm going to go ahead and pick a coordinate system. In this case, this one was created on the design side with an FCS coordinate system. And because it is an assembly model, I'm going to take my part manager, select one part, and then I'm going to add all the instances or all the copies of that one particular part. And I'm going to say OK. Now let's go back. I want to sort these instances. I want to make sure that I work in a grid pattern, top left, horizontally, and in a zigzag fashion. Say OK. And If I wanted to go into my stock manager, I can, and I can manipulate the stock for just one part. It would repeat itself for all the parts. I like this. This is just your basic bounding box, and this will do fine. Same as before, we're going to extract machinable features. If they're prismatic, they should pick up automatically. I'm going to generate those operation plans, and then I'm going to generate the toolpath. And from there, I should be able to simulate and see that it'll be fine. So this is set up where it's going to machine each feature first as opposed to each part first. And in some cases, that is a more efficient way to work. There's less tool changes, so less time taken. And especially on a production part like this, maybe cycle time is of utmost importance. This is something that will help. You would have a hard time doing this if you're programming one part at a time and then doing a subprogram M98 to M99. That would be a nightmare, having to break down the code by tool and making sure that you have proper clearances and all of that. And much of it's handwritten. So this would be all automatically generated with the post-process button right here, and you would have your tools or your features processed first coming across as opposed to finishing one part at a time. Now, if you want to do one part at a time, you can do that. You can just simply go right back into the machine and set up for it to do one part at a time. And it should do that. There we go. That's good enough for us. Now, let's say that we wanted to change the way how we work. And I'd mentioned before about the knowledge base, where you can save your settings if you made an edit to the parameters and have it reemployed. Maybe on my roughing, I'm going to double click my roughing operation here. I want to change my step over. Maybe I'll change it to 20% for some reason. Who knows why? I'll select OK. All right, that should edit the toolpath. I can go back to my operation or my features tree, and that was done in my open pocket profile right here. And I'm going to go ahead and save that operation plan. Make a new one. I'm going to call it my 20% because that's what we did. Save it to my database. I say OK, and I like that. So this is my open pocket profile. Now, if I want that strategy we just changed to automatically be employed every single time I come up with an open pocket profile similar to this, I'm going to go ahead and go into my default feature strategies. I'm going to find something that looks like open pocket. Looks like this guy right here, open pocket. And it's set currently to rough finish. I'm going to find my 20% and make that now, apply that. That is now my default strategy for when I'm creating open pockets. So as I said before, this is where the software can kind of learn with you, and as you make changes and you find a machining habit that you want to employ over and over again, this can automatically employ those things for you. So I'm not going to post-process this. This is 18 parts, and I don't think we need to watch 18 parts, put out into code. That would be a long time. So there you have it, a full assembly with 18 parts, machined in probably the similar amount of time as that turning part. So if I was confident in the strategies and the operations that I've been using, it could be done within a minute or two. This would not happen if I were using what I used to use before. It would take me, at a minimum, an hour to program this. And I know some guys would say even longer. Some guys might say shorter. But this is something where in the shop, again, less clicks, less parameters to change. You get the gist. It's just easier to do. So that's milling with AFR, automatic feature recognition. So on the milling side, it does take advantage of a lot of the features that SOLIDWORKS CAM can provide. Assembly mode is something where fixtures can be used, and it's not essentially something you would do on the lathe, so that's a great thing. But another huge benefit to the milling side is volume mill, which is a high-speed machining toolpath. Now, this reduces the programming time on complex parts. It cuts faster, deeper, with less tool stress, and it's got an even distribution of wear, resulting in longer cutting tool life. So, on top of that, it reduces the load on your machine. Now, what we're seeing here is a part that took only 4.15 minutes, and this is just going to kind of loop and repeat. But if this video is not that convincing, I'll show you this little graphic here. Over here, we have your traditional tool path. It's quarter-inch step down, normal feeds and speeds. This roughing took about 53 minutes, and you know the parameters are pretty conventional. I could say that it wasn't too aggressive, nor was it too conservative. It was just okay. On the other hand, if I go to the volume mill toolpath, the very same feature, the very same part and features that are built, roughing this only took 4.67 minutes. That's a huge time savings. And if you're a shop that has, if you're a job shop that quotes off of a shop rate, take the money that you saved. Just calculate the time that you saved, multiply it by your shop rate, and just figure out how much money you save by utilizing this toolpath or this high-speed machining. And this is something that I think everyone should use, and it works. And 4.67 minutes for this roughing is kind of similar to what we saw in the video before, 4.15 minutes for that whole part to kind of be milled out. So if you can get volume mill, please do use it in your shop. It's a great tool. One of my favorite things about the SOLIDWORKS CAM is its full associativity. And because it's embedded inside SOLIDWORKS, this means if I go and make a change to design, the toolpath will update. So I can change a wall thickness of a pocket, and since the toolpath is fully associated with the model, all it takes is a simple rebuild, and the toolpath update to design change. So this is something that's a great benefit to prototyping environments, people who do a lot of one-offs and proof of concept. It significantly reduces the rework when a design change occurs, and it definitely assures that you will always be machining the current revision of the part, which is a big deal. And I can tell you, I have scrapped entire jobs because I've been working with the wrong print or the wrong model. So this is a really good thing. So when we talk about tolerance-based machining, which is another added feature, it touches on things like PMI and MBD. What are these things? PMI is essentially the product manufacturer's information. And it's just the information that goes along with the part that you're trying to create. And the MBD is model-based design. You're working off of the model as opposed to print. So your models come with tolerances and full GD&T designations. So surface finishes tolerances are already defined onto your model. And what this does is it helps you get into what we call smart manufacturing, using the digital PMI, the MBD, to replace the need for 2D drawings. Tolerance-based machining can generate the toolpaths directly from PMI or MBD data. So if you happen to have a tolerance, in this case we're looking at what 0.0 or 0 to 0.05 millimeters, which is about close to 0.2. If you have a tolerance like that, tolerance-based machining allows you to employ a strategy that can actually achieve that that tolerance and try and be within nominal of that. It even gives you the option of going with a nominal strategy, oversize or undersize. And if you've worked enough in production, you know to account for things like tool wear, especially on something like a 1/10 or 2 tolerance. If I'm making 30 parts and I've got that one reamer that it wants to suggest, how much tool wear am I going to have on that reamer, and how much can I expect over my 30 parts. So this allows you to either undersize or oversize and move towards the mean as you continue with your production run. All right, so we're nearing the end of our webcast here. So definitely want you to walk away from this understanding the differences between the standard and the professional packages. If you are on subscription, you already have SOLIDWORKS CAM Standard. It is a free add-in, and I like to tell people that if you have SOLIDWORKS 2018 or better and are currently on subscription, your CAD is now a CAM also. So to get to that, to get to the SOLIDWORKS CAM, if you've never done it before and didn't know, I'm just going to go ahead and show you. I want you to go right to your Tools tab right here. Find your add-ins. And just click these two right here. That will activate SOLIDWORKS CAM for you. Once you've done that, you can go ahead and start playing and maybe even doing what I did earlier today. So with the standard package, you do get your basic 2.5 axis milling. There's the tolerance-based machining. The AFR, the automatic feature recognition, and the knowledge base, things that we had covered are available, along with the toolpath simulation. It comes with an NC editor that allows you to edit the G code. And then there's a universal post generator also, and that's a tool that allows you to edit a post processor or even help you create one. So this is all the nice and cozy free portion of SOLIDWORKS CAM, and we call it the SOLIDWORKS CAM Standard. If you needed to do any turning, if you have lathes, you're going to have to go into the professional. But that includes things like the assembly machining, a great tool. It allows you to do 4 and 5 axis indexing, and you can use volume mill too. So those are what's within the professional package. If you had capability that's more complex than your conventional mill or lathe, you might be asking what's beyond SOLIDWORKS CAM. And so the next step would be CAMWorks. And CAMWorks is essentially the parent to SOLIDWORKS CAM itself. So there's full data compatibility and it's bi-directional. If you spend a lot of time with SOLIDWORKS CAM and the add-in, you played around with it, you enjoy it, you've done a lot of edits and a lot of customizing the software, that can be upgraded to CAMWorks without issue. You still have your knowledge base and the tech database available for you, along with your models being utilized. Your old files can still be utilized within CAMWorks. We talked a lot about the standard and professional package already, so we kind of have a good understanding of what it offers. But beyond that, the next step would be CAMWorks Standard, which includes the dural turret and subspindle programming. So if you have a subspindle lathe, you can go ahead and use that along with rotary milling on a 4th axis. Then there's Milling Professional, which allows you to do full simultaneous 3-axis milling. It provides mill turn and advanced multitasking. The Turning Professional gives you a sync manager for, say, a multi-turret, multi-spindle setup. So if you want to do things like pinch turning, that's available within Turning Professional. And it provides you a virtual machine standard too, which is a G-code simulator. So your simulator is based off the G-code. And then there's Premium, which is the highest offering within CAMWorks, and that has everything that CAMWorks has to offer, including the 5-axis simultaneous milling. Beyond, so outside of what you see in this matrix, there is an EDM module, a wire EDM. So you can use EDM with CAMWorks. We're going to wrap up the webcast with a summary. We're going to touch off on what we had covered today in the webcast. And we're going to answer the question, how does this help my CNC shop? Well, it's simpler and easier programming. And with AFR, automatic feature recognition, it quickly determines your machining features. This is something, when utilized with the knowledge base and employing things like tolerance-based machining, you can take strategies automatically and keep you within nominal. So there should be less clicks, less menus to navigate, or less parameters to edit, and less mistakes. And because it's feature-based, it's going to be 80 to 90% faster than traditional operations-based programming, especially with AFR supplementing feature-based machining. You can still do operations-based programming. I can use my interactive feature recognition to create features just like I would do on any other CAM out there. But because there is the feature-based avenue or path I can take, it's just so much quicker. Full associativity takes the headache out of design changes. These are things where when quick design changes to the model happen, they automatically reflect into the CAM. It eliminates the hassle of juggling multiple softwares to employ these changes, and it nicely consolidates all the data into one file. Your SOLIDWORKS file with whatever changes you've made is also your CAM file. And because you can take advantage of model-based definition, it should make working with 2D prints a thing of the past, which I think is a good thing. Less paper in the world, and also less confusion, because there's some pretty gnarly prints out there. And this is going to conclude our webcast. I hope you found this informative, and really appreciate you coming out to learn more about SOLIDWORKS CAM.